In this video, we'll continue our discussion of limits. Some notes from last time, we talked about if we're dealing with 0, 0, meaning the limit's going to 0, 0, the first paths that we want to try is x equals 0 and y equals 0. If those do not work, choose other paths. Okay, so here's a couple notes I want to point out here. This first one, be certain the point AB is actually on your path. What I mean by that is if you pick a path right now, okay, if I had x, y, you don't need to write this down or anything, but if it's approaching 2, 3, then I would not want to use x equals 0 as a path. It does not cross or go through, does not go through 2, 3. So we would not want to use it. I would want to use maybe like x equals 2 or something, because that path would go through that. But we would not want to use a path that doesn't go through the point. Okay, so we have to make sure it goes through it. Here's the other method, and you'll see this here in a moment. We're going to try to substitute so degrees of numerator and denominator equal. That's going to be another method if the paths don't work to x equals 0 or y equals 0. And then typically we always choose one of these. So, and I know I put 0, 0 here, but maybe it'd be better to put AB. Choose one of those as a path to begin with, and then come up with another method. Okay, we're going to do a couple problems here, helping you see different methods rather than just the y equals 0 path. So notice we are going through 0, 0, so this is appropriate to use x equals 0 and y equals 0. So we'll say along x equals 0. We'll do that first. So we're going to plug that into our limit. That should be a y. That's approaching 0, 0. And we're going to plug in 3 times 0, y times 3 over 0 squared plus y squared. Okay, notice that that limit, and I wouldn't want to say this is equal to 0 because we need to not plug into an indeterminate form. Notice that we get 0 over y squared. We still would not want to plug in 0 because if I plug in 0, I get an indeterminate form. But I do know that y over 0 is 0. That means the limit is 0. I know it's silly, this whole step right here, but that is what is mathematically correct. If you say that this one is equal to 0, you're right, it is equal to 0. But really, your work is using an indeterminate form. So just be careful. Like I said, I'm not going to count off, but your next professor may. All right. Along y equals 0. That'll be my other path that I'm going to try. So that is the limit as, okay, x, 0 approaches 0, 0. And I'm going to let all the y's be 0 now. You can see how this is going to turn out. All right, so I get the limit. I can drop the y because it's not even there anymore. And I get 0 over 3x squared. This is that silly thing again. So it's the limit as x approaches 0 of 0, which is 0. Well, that doesn't actually do anything for us. We didn't prove that the limit is 0 because we have to show that every path goes to 0. We just have shown 2. Our goal was to show that those go to 2 different things, but it doesn't work. So this actually proves nothing. All right, so it proves nothing. There's nothing to do. Okay, so we're going to pick another path. So let's pick along. Okay, and then the reason I'm doing this is if I notice that I want powers to match on top and bottom. So what I'm going to do is I'm going to let y equal x. If you notice when I plug all this in, okay, let's do that. The limit, okay, as y approaches x. So that's going to be, let's replace y with x. So I got x approaches 0, 0. And then I go through and I replace. Right, if I'm replacing, okay, I got 3 x. And then I got 3x squared plus x squared. So that is the limit as we can drop the double x thing. And we got 3x squared over 4x squared. Notice that this is actually strategic. When I plugged that in, I knew that if I just let that, I was looking here at this denominator, well, if I let that just be x, I can actually add those together, which puts it into one term. And actually the top term, plugging that in as well, I'm manipulating it in a way to make an x squared on top, because now this leads me to the limit as x approaches 0 of 3/4, which is just 3/4. Now we have another path that doesn't go to 0. So since 0 does not equal 3/4, the limit D and E does not exist. So sometimes you're going to pick paths and they're going to give you the same number. That does nothing for us. We have to find another path that gives us something that contradicts the first one. All right, I have another example here. Okay, looking at this one. Let's try first path that we're going to do. We'll do along x equals 0. I always try these first because they're the easiest to plug in. All right, so we get the limit as 0y approaches 0, 0. Okay, I'm going to put 0 everywhere there's an x. So I got 0 times y cubed times cosine of 0, which doesn't matter because I'm going to multiply by 0. And then I got 2 times 0 squared plus y to the 6th. That's going to get me the limit as y approaches 0 of 0 over y to the 6th. You could have just put a big 0 there, because now I'm going to have to write it again. The limit as y approaches 0 of 0, which is 0. All right. We'll do along y equals 0 with high hopes that it will give me another number. So we got the limit of x 0 going to 0, 0. All right, we're going to plug 0 in for y this time. So we got x times 0 cubed cosine x 2x squared plus 0 to the 6th. All right, so I got the limit. I can drop my y's because they're not there anymore. Of x goes to 0. We get a 0 on top and a 2x to the 6th on bottom. That is the limit as x approaches 0 of 0, which is 0. Okay, cool. We gain nothing from that. But we do want to try that every time, because if they're different, we just chose the easiest path to show that on. Now, like above, we were wanting to match powers. So like looking here, I would really like that to maybe add to y to the 6th. So I'm trying to think about 2 times something squared plus y to the 6th, but I want this to come out as 2y to the 6th. I want something in there, that way I can make that work. So that would be my powers. I multiply, that would be a y to the 3rd. So my correct choice here would be x to the y 3rd. I say correct, but hopeful correct, that's going to work. So that is the path I'm going to choose. We have to make sure it goes through the path. Okay, if I plug in 0 for y, I get 0 for x. Okay, cool. So it does pass through 0, 0. So that's my path, x equals y cubed. All right, let's do that. Okay, replacing that first y. Well, this one's a little weird. I'm going to, let's write it down. Y to the 3rd. Y approaches 0, 0. All right, and then we go through and we'll do all the replacing. Okay, so I do get 2 y to the 6th plus y to the 6th on bottom, and I'm hoping up top is probably going to give me a y to the 6th as well. Okay, so it's y to the 3rd times y to the 3rd times cosine of y to the 3rd. Okay, so I'm going to go down here. This limit, because y to the 3rd approaches 0 when y approaches 0, I can just change it to y is 0. Y approaches 0. And that's just because they both approach 0 in the same way. Well, not in the same fashion, but they both approach 0. Okay, so we get then y to the 6th cosine y to the 3rd over 3 y to the 6th. And then what we wanted to happen is going to happen. The y to the 6's go away, and I just get a third cosine y to the third. Well, I can plug that in. That's 1/3 cosine of 0. And cosine of 0 is not 0, it's 1. So that gets me a 1/3, which is what I was looking for. Something that wasn't 0, right? I wanted this to not match those. So, since 0 does not equal 1/3, the limit doesn't exist. So the whole key is you got to find something, two numbers that contradict each other. Sometimes you can go on a goose chase, right? Trying to find, I think that's the phrase for that. But trying to find some path. You may pick something, you may pick 4 paths that all go to 0. That's okay. If I ask you to show it doesn't exist, that means it doesn't exist. If you get on a test and you're doing something wrong at that point, or the problem's wrong. If the problem's wrong, I always just throw them out. Okay, so that's how we prove limits don't exist.